Welcome back to e-CBSE online classes. We are continuing the module Arithmetic Progressions for class 10th. We are in the middle of solving some exercise problems. This is part B4 of the video series in this module. Before we start doing the exercise problems, let us quickly recap the key formulae. The arithmetic progression is denoted by A1, A2, A3, etc. The common difference D can be found out by any two consecutive numbers difference, either A2 minus A1 or A3 minus A2 and so on. And the general form of the arithmetic progression is given as A plus D, A plus 2D and so on, A plus n minus 1 into D and so on. The general form of the nth term is An equal to A plus n minus 1 into D. The sum of first n terms in an arithmetic progression is given by S is equal to n by 2 times 2A plus n minus 1 into D. In the previous video, we have solved some problems related to the general form of the nth term. We are going to solve few more problems in this video. Let us look at the exercise problem number 7. It reads, which term of the AP 3, 8, 13, 18 and so on is 78? The formula that we need to use is general form of the nth term, that is An equal to A plus n minus 1 into D. The common difference D can be found out by taking difference between any two consecutive numbers, that is A2 minus A1 or A3 minus A2 or A4 minus A3 or so on. The first number is 3, so A equal to 3 and An equal to 78 because that's what we need to find out. And D can be found out by using the first two terms, that is A2 minus A1 here, that is 8 minus 3 equal to 5. So we substitute A, An and D in the above formula. That becomes 78 is equal to 3 plus n minus 1 into 5. After rearranging, it becomes n minus 1 into 5 is equal to 78 minus 3, that is 75. So n equal to 75 by 5 plus 1, that is 15 plus 1, that is equal to 16. So 78 is 16th term of the given arithmetic progression. Let's look at the next problem. It reads, check whether minus 150 is a term of the arithmetic progression 11, 8, 5, 2 and so on. Again, the formula to be used is general form of the nth term, that is An equal to A plus n minus 1 into D. Common difference D can be found out by taking a difference of any two consecutive numbers. Here the first term is given as 11, so A equal to 11. An is minus 150 because that is our target number. Common difference D, I am using the first two terms, so A2 minus A1, that is equal to 8 minus 11 equal to minus 3. So substituting all the values of A, An and D into the above formula, it becomes minus 150 equal to 11 plus n minus 1 times minus 3. Rearranging this equation, it becomes n minus 1 into 3 is equal to 11 plus 150, that is 161. So n is calculated as 161 by 3 plus 1. It's coming out as 54.67. The problem we are given is check whether minus 150 is a term of the arithmetic progression. So for any number to be a term of a given arithmetic progression, the value of n calculated should be an integer. Here n is 54.67, so it's not an integer because there are some decimal points as well. So the answer is minus 150 is not a term of the given arithmetic progression. Let's go to the next exercise problem here. It reads, find the 31st term of an arithmetic progression whose 11th term is 38 and the 16th term is 73. Again, the common form of the nth term, that's what we need to use. We are given 11th term as 38. 11th term is nothing but A plus 10D. So A plus 10D is equal to 38. Let us call that as equation 1. And what else is given here? 16th term, that is A16 equal to 73. 16th term is A plus 15D. So A plus 15D is equal to 73. Let's call that as equation 2. So we subtract equation 1 from equation 2 to eliminate A. That becomes 5D equal to 73 minus 38 equal to 35. So D is equal to 35 by 5, that is 7. Now let's substitute this value of D in equation 2. That becomes A plus 15 times of 7 is equal to 73. 15 times of 7 is 105. So A is equal to 73 minus 105. that is minus 32. So a is minus 32 and d equal to 7. What we need to calculate here? The 31st term, that is a31 is equal to a plus 30d. Let's substitute the values of a and d here. That becomes minus 32 plus 30 into 7. 30 into 7 is 210. So a31 is minus 32 plus 210, that becomes 178. So the answer is 31st term of the given arithmetic progression is 178. Let's solve another problem here. It says the 17th term of an arithmetic progression exceeds its 10th term by 7. Find the common difference. The formula to be used is again the same. What is given here? 17th term, that is a plus 16d, and 10th term, that is a plus 9d. But we are not given the values of these terms. Instead, we are given the difference of these. So a17 minus a10 is equal to 7. Correct? So let us substitute the expressions for a17 and a10 in this equation. That becomes a plus 16d minus a plus 9d is equal to 7. Here both a gets cancelled here. That leaves 16d minus 9d, which is 7d. 7d equal to 7, so d equal to 1. That's all we need to find out here. It's a very simple problem. So the common difference in this arithmetic progression is 1. Let's move on to another problem. It reads, two arithmetic progressions have the same common difference. The difference between their 100th terms is 100. What is the difference between their 1000th terms? The formula to be used is the same, the general form of nth term here. Let us call a prime and d prime define the first arithmetic progression, and a double prime and d double prime define the second arithmetic progression. These superscripts are basically to distinguish between the two arithmetic progressions. So what is given to us? 100 terms difference, correct? So 100 terms of the first arithmetic progression is a prime plus 99d prime, and the same for second arithmetic progression is a double prime plus 99d double prime. We are given the difference between these two terms is 100. So if we substitute the corresponding expressions here, that becomes a prime plus 99d prime minus a double prime plus 99d double prime is equal to 100. So we know that, or we are given that they have the same common difference. That means d prime is equal to d double prime equal to d. So the above expression becomes a prime plus 99d minus a double prime plus 99d is equal to 100. So 99d and 99d gets cancelled. What we are left with is a prime minus a double prime is equal to 100. Let's remember this and keep it aside. Now what we are supposed to find out is the difference between their 1000th terms, correct? Let's write the 1000th term for the first arithmetic progression. That becomes a prime plus 999d prime, and the 100th term for the second arithmetic progression is a double prime plus 999d double prime. What we need to calculate is the difference between these two. That becomes a prime plus 999d prime minus a double prime plus 999d double prime. Again, we know that d prime and d double prime are equal. Let us substitute that with d. It becomes like this, and 999d and 999d gets cancelled. So what we are left with is the difference between 1000th term of these two arithmetic progressions is a prime minus a double prime, which is already calculated above as 100. So the difference between 1000th terms of the given arithmetic progressions is 100. So not only 1000th term, you take any corresponding term of these two arithmetic progressions, that should be equal to 100 because their common difference is same. Now let's go to the exercise problem number 12. It says how many 3-digit numbers are divisible by 7? The formula is same. The common term of nth term an is equal to a plus n minus 1 into d. Here let's find out the 3-digit numbers. That is, it starts from 100, 101, 102, etc. and it goes up till 999, correct? So we need to identify the first value of this series, or rather arithmetic progression. So the minimum numbers are like 100, 101, etc. Right? What we need to identify is the first number of the arithmetic progression. So the keyword here is divisible by 7, correct? That means our common difference also will be equal to 7. And what would be our first term? That is the smallest 3-digit number which is divisible by 7. So let's start with the smallest number here, 100. Is it divisible by 7? No. 101 is also not divisible by 7. Not even 102, not even 103, not even 104. Now 105 is divisible by 7. So 105 is our smallest 3-digit number which is divisible by 7. That becomes our first term. So a equal to 105. And what about the last term or nth term here? So let's take the highest 3-digit numbers. Let us take 9 numbers here. So our last term would be the largest 3-digit number which is divisible by 7. 999 is not a multiple of 7. 998 is also not. 997 is also not divisible by 7. Same is the case with 996 and 995. So 994 is divisible by 7. So that becomes our last term or nth term. So let us call that as an. An equal to 994. So we have 3 terms out of the 4 terms in the above expression. The expression is an equal to a plus n minus 1 into d. Let us substitute the values of an, a and d. It becomes 994 is equal to 105 plus n minus 1 into 7. Rearranging this, it becomes n minus 1 into 7 is equal to 994 minus 105. That becomes 889. So n is equal to 889 by 7 plus 1. That is equal to 127. So we got value of n equal to 127. That means the total number of 3-digit numbers which are divisible by 7 are 127. Correct? Before wrapping up this video, let us quickly look at some general steps to solve such problems using nth term of arithmetic progression. We know that the general formula or general form of the nth term is an equal to a plus n minus 1 into d. Notice that there are 4 terms in this expression. So any 3 is given, you can calculate the remaining 4th term, correct? So what are the typical questions asked in this kind of problems? Find nth term an of arithmetic progression, or how many terms are there in an arithmetic progression, or is a particular number a term in the arithmetic progression, correct? What we need to remember is the first term a and common difference d define an entire arithmetic progression. We need to understand the problem first. Typically when the problem is given in the form of a text, you need to understand that and look for the keywords, correct? And use the formula of nth term to write equations. If required, once you get the equation, solve them to get the values of a and d and calculate the desired values. The desired values will be usually the nth term an or number of terms n. And to answer the last question, whether a particular number is a term in the arithmetic progression, we need to remember that the calculated value of n should be an integer. If n is not an integer, then the given number is not a term of the arithmetic progression. Okay, so these are the steps. Please keep these in mind and stay tuned for the next video. We are going to solve some problems on the formula for sum of the first n terms. I hope you like this video. Please like, share, comment and subscribe to our channel e-CBSE online classes and follow us on Facebook page. Thank you so much for joining.